NTT's future vision, IOWN. Using the three-layer structure shown here, IOWN achieves advanced information transfer and processing, leading to the realization of a smart society. The foundation of IOWN is the All-Photonics Network. The parts of the network closest to users are the optical access networks. Let us introduce a new type of access network conceived for IOWN. This is the current optical access network. It has a star topology with an NTT building in the center. To be usable in IOWN, a network in a star topology needs to satisfy three requirements. The first is reliability. Since the NTT building and each user is linked with a single cable path, the service is interrupted if the cable is damaged. The second requirement is tolerance for uncertainties in service demand. When high demand arises in an unexpected place, a new cable needs to be installed. The third requirement is path selectivity. Even when a base station communicates with an adjacent base station, it has no other choice but to use a path via the NTT building. NTT laboratories have studied how to satisfy these requirements from a topological perspective and conceived a new reliable optical access network. This is an optical access network design based on concatenated loop topology. A circular optical fiber loop, called the primary loop, is built with an NTT building at its center. Secondary loops are connected to the primary loop via fiber cross-connection. Base stations are connected to the secondary loops. In this network, multiple paths are available between the NTT building and each base station. Since standby paths can be installed in advance, reliability is enhanced. Also, an unexpected increase in demand can be promptly satisfied by flexibly reassigning fibers. Thus, tolerance for uncertainties in service demand dramatically improves. A base station can communicate with an adjacent base station without going through the NTT building. Thus, flexible path selectivity is achieved. This optical access network design, based on concatenated loop topology, can be installed without modifying the existing optical access networks. Thus, new optical access networks come into being in which two types of network coexist. These optical access networks can speedily respond when high demand arises. Smart life, automated driving, telemedicine, agriculture and construction industries, and large mass events. Optical access networks will continue to evolve to reliably support these various services made possible by IOWN.